Lightsabers are just immensely cool. That one's a special effect, by the way, just in case you hadn't guessed. But give us a thumbs up if you'd like a real one, a real life lightsaber. Yeah? Well, you can't, I'm afraid. I'm sure you knew that. We can't make them because the power requirements alone are just immense. But that's just a technological limitation. Doesn't mean they're fundamentally impossible. So we could have lightsabers in the future. That being said, the pesky laws of physics means owning a lightsaber would possibly be one of the most dangerous things imaginable. Before we get onto the problem with lightsabers though, let's just make sure we understand how you'd make one in real life. Lightsabers, as I'm sure you know, are blades of hot plasma. Yes, that is canon. Now plasma, for the time being, think of that as just being a hot gas. So hot in fact that it ionizes, the electrons get ripped off of the atoms. I plan on doing a video in more detail about what plasmas are and where you find them, so make sure you subscribe to check that out. Now, the blade is glowing because the plasma is so hot. They act like a black body, much like the sun does. So using Planck's handy formula, we can work out exactly how hot they are. If you are a fan of the dark side, for instance, with a red Sith lightsaber, you're talking 1000 Kelvin. Whereas if you veer more towards the light, a nice blue lightsaber like Anakin Skywalker used to have, well then you're talking a whopping 15,000 Kelvin. You definitely don't want to get any of that on you. So how do we stop it? Well, the answer is, as Jesse Pinkman would say, magnets! The thing that determines how strong a magnetic field you need is a thing called the plasma beta. That's the ratio of the thermal pressure of the plasma to the magnetic pressure trying to confine it. Now obviously we want a beta smaller than 1 to keep it inside a blade shape. Tokamaks, for instance, used in nuclear fusion reactions and research that's going on right now, typically have plasma betas of about 0.1. So if we apply that number to our lightsaber figures, well, we need really big magnetic fields, between 6 and 23 Tesla. And to put that into perspective, the superconducting magnets at the LHC, which are massive, are 8.4 Tesla. Not an easy feat. Now in plasma physics, magnetic fields and plasmas are tied together. We call them frozen in. If we move one, the other moves with it. So we're not going to lose our plasma by swinging our lightsaber blade around. The other cool thing with the frozen in condition is it means plasmas from different sources cannot mix. So if we swing our lightsaber and go to hit another one, they should clash just like in the movies. Except when that thing breaks down, which it does. Yep, now we're on to the problem. You see, there's this fundamental plasma process called magnetic reconnection, which can release a huge amount of energy when plasmas with different magnetic fields collide. For instance, the aurora, or the northern lights, are caused by the solar wind reconnecting with Earth's magnetic field when they're oppositely aligned. And that's just a huge amount of energy being dumped into the top of the atmosphere in the form of hot electrons. Now you might be thinking, okay, well, we'll just make sure all lightsabers are set in the same direction so this doesn't crop up. But it's not as easy as that. There's an equation which determines when reconnection can occur. And here it is. The three things involved are the angle between the magnetic fields, which in this case you can think of as the angle between the two lightsabers. You've also got the difference in the plasma betas of those two lightsabers and the distance between the two blades in terms of something called the ion inertial length. Now, we know the plasma betas have to be small to confine the plasma into their blades, so the difference in those has to also be a small number. And for lightsabers, it turns out that the ion inertial length is absolutely tiny, just 0.1 microns. So the distance between the two blades in this case will also be quite big. And that means that if you were to have a lightsaber fight, you pretty much get reconnection going on all the time unless you could get them exactly aligned when they clashed. Now you might ask, well, why do I care? Surely it's not going to be that bad. Well, it is. Reconnection releases a huge amount of energy, not only in the form of jets of that hot plasma traveling at some 3 to 13 kilometers a second. That's the same speed as most explosions. So at the clash of two lightsaber blades, huge amounts of hot plasma are going to be ejected at explosive velocities, and they're going to vaporize your hands, legs, and face off. And not in a fun Nicolas Cage way. That's why I don't want one of these. Thanks for watching this video about lightsabers. Sorry if I've ruined your childhood dreams. Just buy a toy, it'll be fine. In the meantime, make sure you subscribe to my channel, or you can click to check out some of the stuff I've done for other people. Thank you.